I've been using Visual Studio Code for all my Python development for quite some time. And when I say Python development, of course, I mean data science. And I have made a couple of videos, and I actually do use the agent inside of Visual Studio Code with GitHub Copilot, and that really works well. But what I thought I'd do today is just take a look at OpenAI's Codex. Now, let's be honest, that is for application development, but I wanted to say see what can we do with data science. So I do have Codex installed in Visual Studio Code. Have a look at this website. And this is what you'll have to do. Now, it is going to be available for people on the Pro plan and the higher plans. Now, I do pay for the Pro plan, so we've got to bear that in mind. That is what this video is about, or some restrictions at least for this video. This is the web page that you'll go to, and you're going to click on install, and you're going to have Codex available right inside of Visual Studio Code. And so let's take a look. Can we set up an agent to do some data analysis for us in a Jupyter notebook just using OpenAI Codex? So with all of that out of the way, I've opened my Visual Studio Code here. I'm going to open the Explorer, top left, and then I'm just going to drag my folder from my Finder into this empty section. My folder is called Testing Codex, and you can see we've got 3 files. I've got my CSV file containing the data. I've got 2 other files, a hard CSV data dictionary and my instructions file. So let's open this. They are both just markdown files, so very simple to do. And as you can see here, there is my data dictionary. Now, it doesn't fit on the screen, so it looks a bit weird. So let's just go through it quickly. I'm using simple markdown, so single hashtag just denotes the largest font size. So if you printed this out, this would be the title. So it's data dictionary for the hard.csv file. Look at what I've done. I do put quotation marks there to indicate that this is a string. I put that inside of tick marks just to show that if this was used in code, that would be code. And then it's very simple. The document provides detailed descriptions of the columns present in the hard.csv dataset, which contains information related to this dataset. Now, what I'm going to do, I'll just show you the following. I've just opened it in the text editor. I've made the font very small so you just can see what this would look like. It's just a big column. And so in Markdown, this is how you'd create a column, just with this little pipe symbol on your keyboard. There's my header row, my second row with this. You won't be able to see on YouTube, I'm sure, but a little colon there on the left-hand side, just indicate that this must all be left aligned. And I've got a column name, a data type, a description, encoding, just to say if I'm using encoding, M means male, F means female, 0 means no heart disease, 1 means heart disease, typical of that. I'm also indicating here in these 2 columns, again, too small to see, but it says 0 values indicate missing data. And that's how missing data was indicated in this data file, just to be sure that those values, when we calculate means, and etc., some statistic, that we do not include those zeros. And then I've got an alternatives column, because if you look at the header names later in the data file, those header columns contain underscores, and those are abbreviated words. And even the data inside of the columns, sometimes there's just abbreviations like ASY for asymptomatic, etc. And so on my right-hand side, I've got this alternatives column, and all I'm doing in this alternatives column is just to say, look, this is the abbreviated word, and this is the proper word. So it says use resting electrocardiogram or ECG instead of resting ECG, and there's no space in that column header name. So when it creates plots, it just does a better job. You don't see these underscore words and abbreviated words in the plots. And so that's what the rest of this document looks like. And a data dictionary, I feel, is always very, very important when you're using AI, so that the model can understand, what your spreadsheet is. And then I've got an instructions.md file. Now, again, just to mention that I will put this all in the description down below so that you can read all of this yourself. And these are my instructions. My instructions are, let's just increase the size a little bit. Create a Jupyter notebook. Let's make some more space. Create a new Jupyter notebook in the current folder to do exploratory data analysis of the data in the hard CSV file. Let's just put the file, just to be clear, using the data dictionary file, hard CSV data dictionary.md. Asks me to choose a Python kernel for the notebook, take a stepwise approach. For example, create the notebook and open it in the editor. Then let me select the Python kernel. Then execute the notebook cell by cell, edit as it's created, and write findings in markdown cells below code cells with output where needed. I don't want those print statements, to generate the report just with a bunch of print statements. I want a new Markdown cell and write your report inside of Markdown cells. So then I've got general notebook instructions. I've got 7 of them here. Use Markdown cells with these hashtag symbols for titles, sections, and subsections. Import the required packages in the first section named import Python packages. Add the code %config, that's the magic command, just so that we have high resolution display. I put those inside of this little tick marks just to indicate to the LLM. It's very good at doing that sort of thing when it recognizes that you are trying to write code inside of your instructions. Do that in the import section to create high resolution plots. The next sections should be data import the spreadsheet and assign it to the variable df, again in little tick marks. It's code. The final section should be exploratory data analysis. Use appropriate title and access labels for plots. Use LaTeX in title and access labels where appropriate. Always add a grid to plots, just something that I like. Do not use column header variable names in the hard CSV file in the reports or plots. The column headers have abbreviations and underscores. Instead, use the information in the alternatives column. Let's just close those quotation marks in the data dictionary when creating plots and reports. Never use the print statement. Rather create Markdown cells and interpret the results in Markdown text. I repeat, do not use the print function to create interpretations from results. And then my data analysis instructions are use subsections in the final section, exploratory data analysis for each variable or column in df. For each variable, calculate summary statistics and data visualization. In the case of numerical variable, calculate the sample mean, variance, standard deviation, minimum, first quartile, median, third quartile, and the maximum, and then create a histogram of the values. Do not use a set number of bins. I don't like that because then there's misalignment of your rectangles. Rather use specified bin intervals at integer intervals such as 10 to 15, 15 to 20, 78 to 80. Let's put a comma there. In the case of a categorical variable, calculate the frequency and the relative frequency of each cluster in the variable and then create a bar plot. So those are my instructions. Now I've already set up Codex. You can see it's right there. And you can do that by following instructions. Just look it up on the OpenAI website. It'll give you instructions. And there we have Codex. I'm going to click on it and it opens up all this information for me. And I'm now simply going to say, tell it, I've got these files and please just use them. I'm going to say, analyze the data in the, let's put that in quotation marks. I'm going to say heart.csv file. So there you go. I've typed analyze the data in the hard CSV file with information in the hard CSV data dictionary .md file, follow instructions in the instructions.md file. Now, just to be sure, let's just add these files as context. And I'm going to search for these files. So it's going to be hard.csv. Right, we've got that one. Let's do the dictionary file as well. And let's just do the instructions file. So I'm just typing in those words, it finds the file in the folder. So it's got all 3 of those files right there for context. I'm going to cross my fingers and we're just going to hit send. It's thinking, it's done its little to-do list there. And it's going to take some time. Let's do a stopwatch and see what happens. Now it seems it wants to create a virtual environment here instead of letting me select my Python environment, which is not exactly what I wanted, but let's do that. I'm just going to say approve once. Once to activate it, I'm going to say approve once again. So at the 6-minute 36-second mark, it said, do I want to use another kernel? So this is doing that, but it's already created this virtual environment. So I'm just going to say the V in V is good. Again, I put that inside of little tick marks just to show that should be interpreted as code. So that's good. So let's open up our Explorer there, and we see there is indeed an IPYNB file, and we can also see that a virtual environment was created. So let's open the file and let's see what Codex has done. So it's got a nice little title, heart disease data set, exploratory data analysis. The Snowbird performs an exploratory data analysis or EDA of the heart.csv file using the definitions and encodings in the dictionary file. That's fine. It's done all these imports, data import, then the exploratory data analysis. And it's done created some functions. Then it does age, sex, chest pain. It wants to add all these interpretations. I'm not quite sure how all of that's going to work. So let's select our kernel. I'm going to say select Python kernel and the virtual environment that was selected. That's good. Let's go back to Codex and say I have selected. Let's say I've selected the virtual environment and just continue. I'm just going to begin the timer again. So that was 6 minutes 36 seconds to create that notebook. We've selected the environment, the virtual environment that it's created, and it's now going to try and execute the notebook and hopefully, add the results that we required. So while it's running, I'm just going to close this notebook that was generated because obviously it's not complete, and I'm just going to say don't save because it is going to rewrite that. Let's also close this instruction file, say save. And so it's been another 6 minutes or so. While it says finished working here at the bottom, this still seems to be running considering dataset details. Let's just open our Explorer again. Let's open the IPython notebook. And we see actually that we do have some results. So let's open that up and have a closer look. So again, we have our title, and we have import the Python packages as required. We've got data import, and it's printing the first couple of rows for us there. And the exploratory data analysis, we see the results, for instance, for the age column, mean of 53, all the way to the minimum 28, maximum 77. And we see that we do have that histogram, and it is as indicated, such that we do have these bins at least on integer values. I'm just going to go back to the top and just have a look. We do see that we do have high resolution display there, so that worked out well. And we do see the sort of summary of the results there. Let's have a look at 6. We see the frequency, relative frequency. We see the bar plot there, and very nicely done. It's not written 0 and 1. It's written male and female. And let's just go down. There seems to be a little mistake right there. If I click on that, we can see what went wrong with the LaTeX there, but we can certainly fix that ourselves. Let's look at the code, and again see it's replacing the zeros with NaN values, and NumPy NaN values, so not a number, so that when these calculations are done, 0 is not included. So we see the minimum age is not 0 but 80. The minimum, I should say, blood pressure is not 0 but 80. So it's done all of that very well. Still the mistakes with the LaTeX there, but we can certainly fix those. And the blood pressure, blood sugar there, was it greater than 120 milligrams per deciliter? That's fine. And let's have a look at these. Normal left ventricular hypertrophy, ST, T-wave abnormality. So it's done all of that. Looks like it's done that correctly. Let's go to the bottom of the page. There we go. It seems to have done quite well. We don't see any real interpretation of the results. I've done another video on using the databot and positron, and that gives nice little summaries. But I suppose this is good. You are supposed to go through the code, see that everything is correct, and perhaps then look at these summaries and interpret them sort of yourself, which is the best thing to do, not to let the LLM do all of these. I'm just going to restart this and say restart our kernel, and I'm just going to say run all, so that we execute all of this code ourselves, and everything seems to work. That's very good. And so there we go. There we go. Again, we'll just have to fix those LaTeX errors in the section and subsection markdown cells, but I think that is not too bad. And there you have it. You've got your populated notebook by just using Codex. I think with a little bit of tweaking, better instructions, and then if we go back to Codex, if we just do a little bit more in the way that we chat, things that we might get it to do or redo, I think this is really not too bad. I cannot see myself using the Codex for this right at the moment. I'm still very happy if I open the right-hand side just to use the agent here on the right-hand side, set up an agent. I do have videos out on that on the channel, so you can have a look at those. I think just using the build with the agent here instead of using OpenAI Codex on this side. But as you can see, I think this is totally workable. And why don't you take one of your own data sets, explore it a little bit, and see what you can do. Perhaps next time we should just do something a bit more exciting. Maybe we should get some statistical tests in here, build some models, and see what it can do.